recovery in the same conditions. As a result, de Havilland reprofiled the wing's leading edge with a pronounced droop, and wing fences were added to control span-wise flow. A fictionalized investigation into the Comet's takeoff accidents was the subject of the novel Cone of Silence, 1959, by Arthur David Beattie, a former Borg captain. Cone of Silence was made into a film in 1960, and Beattie also recounted the story of the Comet's takeoff accidents in a chapter of his non-fiction work, Strange Encounters, Mysteries of the Air, 1984. The Comet's second fatal accident occurred on the 2nd of May, 1953, when Borg Flight 783, a Comet 1, registered GALYV, crashed in a severe thundersquall 6 minutes after taking off from Calcutta Dum Dum, now Netaji Subhash Chandra Bose International Airport, India, killing all 43 on board. Witnesses observed the wingless comet on fire plunging into the village of Jagalgiri, leading investigators to suspect structural failure. India Court of Inquiry, edit. After the loss of GALYV, the Government of India convened a court of inquiry to examine the cause of the accident. Professor Nathan Srinivasan joined the inquiry as the main technical expert. A large portion of the aircraft was recovered and reassembled at Farnborough, during which the breakup was found to have begun with a left elevator spar failure in the horizontal stabilizer. The inquiry concluded that the aircraft had encountered extreme negative G-forces during takeoff. Severe turbulence generated by adverse weather was determined to have induced downloading, leading to the loss of the wings. Examination of the cockpit controls suggested that the pilot may have inadvertently overstressed the aircraft when pulling out of a steep dive by over-manipulation of the fully powered flight controls. Investigators did not consider metal fatigue as a contributory cause. The inquiry's recommendations revolved around the enforcement of stricter speed limits during turbulence, and two significant design changes also resulted. All Comets were equipped with weather radar and the Q-field system was introduced, which ensured that control column forces, invariably called stick forces, would be proportional to control loads. This artificial feel was the first of its kind to be introduced in any aircraft. The Comet 1 and 1AM had been criticized for a lack of feel in their controls, and investigators suggested that this might have contributed to the pilot's alleged overstressing of the aircraft. Comet chief test pilot John Cunningham contended that the jetliner flew smoothly and was highly responsive in a manner consistent with other de Havilland aircraft. Comet Disasters of 1954, edit. Main articles: Borg Flight 781 and South African Airways Flight 201. Just over a year later, Rome Ciumpino Airport, the site of the first Comet hull loss, was the origin of a more disastrous Comet flight. On the 10th of January, 1954, 20 minutes after taking off from Ciumpino, the first production Comet, GALYP, broke up in midair while operating Borg Flight 781 and crashed into the Mediterranean off the Italian island of Elba with the loss of all 35 on board. With no witnesses to the disaster and only partial radio transmissions as incomplete evidence, no obvious reason for the crash could be deduced. Engineers at de Havilland immediately recommended 60 modifications aimed at any possible design flaw, while the Abel Committee met to determine potential causes of the crash. Borg also voluntarily grounded its Comet fleet pending investigation into the causes of the accident. Abel Committee Court of Inquiry, edit. Media attention centered on potential sabotage. Other speculation ranged from clear air turbulence to an explosion of vapor in an empty fuel tank. The Abel Committee focused on 6 potential aerodynamic and mechanical causes: control flutter, which had led to the loss of DH-108 prototypes; structural failure due to high loads or metal fatigue of the wing structure, failure of the powered flight controls, failure of the window panels leading to explosive decompression, or fire and other engine problems. The committee concluded that fire was the most likely cause of the problem, and changes were made to the aircraft to protect the engines and wings from damage that might lead to another fire. The cost of solving the Comet mystery must be reckoned neither in money nor in manpower. Prime Minister Winston Churchill, 1954. During the investigation, the Royal Navy conducted recovery operations. The first pieces of wreckage were discovered on the 12th of February, 1954, and the search continued until September, 1954, by which time 70% by weight of the main structure, 80% of the power section, and 50% of the aircraft's systems and equipment had been recovered. The forensic reconstruction effort had just begun when the Abel Committee reported its findings. No apparent fault in the aircraft was found, and the British government decided against opening a further public inquiry into the accident. The prestigious nature of the Comet project, particularly for the British aerospace industry, and the financial impact of the aircraft's grounding on Bork's operations both served to pressure the inquiry to end without further investigation. Comet flights resumed on the 23rd of March, 1954. On the 8th of April, 1954, Comet GALYY, Yoke, on charter to South African Airways, was on a leg from Rome to Cairo, of a longer route, SAF Flight 201 from London to Johannesburg, when it crashed in the Mediterranean near Naples with the loss of all 21 passengers and crew on board. The Comet fleet was immediately grounded once again, and a large investigation board was formed under the direction of the Royal Aircraft Establishment, RAE. Prime Minister Winston Churchill tasked the Royal Navy with helping to locate and retrieve the wreckage so that the cause of the accident could be determined. The Comet's certificate of airworthiness was revoked, and Comet 1 line production was suspended at the Hatfield factory while the Bork fleet was permanently grounded, cocooned and stored. Cohen Committee Court of Inquiry, edit. On the 19th of October, 1954, the Cohen Committee was established to examine the causes of the Comet crashes. Chaired by Lord Cohen, the committee tasked an investigation team led by Sir Arnold Hall, director of the RAE at Farnborough, to perform a more detailed investigation. Hall's team began considering fatigue as the most likely cause of both accidents and initiated further research into measurable strain on the aircraft's skin. With the recovery of large sections of GALYP from the Elba crash and Bork's donation of an identical airframe, GRU, for further examination, an extensive water torture test eventually provided conclusive results. This time, the entire fuselage was tested in a dedicated water tank that was built specifically at Farnborough to accommodate its full length. In water tank testing, engineers subjected GRU to repeated repressurization and overpressurization, and on the 24th of June, 1954, after 3,057 flight cycles, 1,221 actual and 1,836 simulated, GRU burst open. Hall, Geoffrey de Havilland and Bishop were immediately called to the scene, where the water tank was drained to reveal that the fuselage had ripped open at a bolt hole, forward of the forward left escape hatch cutout. The failure then occurred longitudinally along a fuselage stringer at the widest point of the fuselage and through a cutout for an escape hatch. The skin thickness was discovered to be insufficient to distribute the load across the structure, leading to overloading of fuselage frames adjacent to fuselage cutouts. Cohen Inquiry Accident Report Fig. 7. The fuselage frames did not have sufficient strength to prevent the crack from propagating. Although the fuselage failed after a number of cycles that represented 3 times the life of GALYP at the time of the accident, it was still much earlier than expected. A further test reproduced the same results. Based on these findings, Comet 1 structural failures could be expected at anywhere from 1,000 to 9,000 cycles. Before the Elba accident, GALYP had made 1,290 pressurized flights, while GALYY had made 900 pressurized flights before crashing. Dr. P.B. Walker, head of the structures department at the RAE, said he was not surprised by this, noting that the difference was about 3 to 1, and previous experience with metal fatigue suggested a total range of 9 to 1 between experiment and outcome in the field could result in failure. The RAE also reconstructed about 2/3 of GALYP at Farnborough and found fatigue crack growth from a rivet hole at the low-drag fiberglass forward aperture around the automatic direction finder, which had caused a catastrophic breakup of the aircraft in high-altitude flight. The exact origin of the fatigue failure could not be identified but was localized to the ADF antenna cutout. A countersunk bolt hole and manufacturing damage that had been repaired at the time of construction using methods that were common, but were likely insufficient allowing for the stresses involved, were both located along the failure crack. Once the crack initiated, the skin failed from the point of the ADF cutout and propagated downward and rearward along a string, resulting in an explosive decompression. It was also found that the punch rivet construction technique employed in the Comet's design had exacerbated its structural fatigue problems. The aircraft's windows had been engineered to be glued and riveted, but had been punch riveted only. Unlike drill riveting, the imperfect nature of the hole created by punch riveting could cause fatigue cracks to start developing around the rivet. Principal investigator Hall accepted the RAE's conclusion of design and construction flaws as the likely explanation for GRU's structural failure after 3,060 pressurization cycles. 1. Borg Comet 1 cocooned and stored in the maintenance area at London Heathrow Airport in September 1954. 2. Image from the Cohen inquiry report showing fuselage failure underwater pressure test of Comet 1 GRU. Note: intact escape hatch window frame. 3. The ADF antenna penetration that failed on GALYP at the Science Museum in London. 4. Image, Fig 12. From the Cohen inquiry showing the location of the ADF antenna cutout windows in the roof above the cockpit of Comet 1 GALYP. Earlier structural indications, edit. The issue of the lightness of Comet 1 construction, in order to not tax the relatively low-thrust de Havilland Ghost engines, had been noted by de Havilland test pilot John Wilson, while flying the prototype during a Farnborough fly-past in 1949. On the flight, he was accompanied by Chris Beaumont, chief test pilot of the de Havilland Engine Company, who stood in the entrance to the cockpit behind the flight engineer. He stated, "Every time we pulled 21/2-3G to go around the corner, Chris found that the floor on which he was standing bulging up, and there was a loud bang at that speed from the nose of the aircraft where the skin panted, flexed, so when we heard this bang we knew without checking the airspeed indicator, that we were doing 340 knots. In later years we realized that these were the indications of how flimsy the structure really was." Square window myths, edit. Despite findings of the Cohen inquiry, a number of myths have evolved around the cause of the Comet 1's accidents. Most commonly quoted are the square passenger windows. While the report noted that stress around fuselage cutouts, emergency exits and windows was found to be much higher than expected due to de Havilland's assumptions and testing methods, the passenger window's shape has been commonly misunderstood and cited as a cause of the fuselage failure. In fact, the mention of windows in the Cohen report's conclusion refers specifically to the origin point of failure in the ADF antenna cutout windows, located above the cockpit, not passenger windows. The shape of the passenger windows were not indicated in any failure mode detailed in the accident report and were not viewed as a contributing factor. A number of other pressurized airliners of the period, including the Boeing 377 Stratocruiser, Douglas DC-7, and DC-8, had larger and more square windows than the Comet 1, and experienced no such failures. In fact, the Comet 1's window general shape resembles a slightly larger Boeing 737 window mounted horizontally. They are rectangular, not square, have rounded corners, and are within 5% of the radius of the Boeing 737 windows and virtually identical to modern airliners. Paul Wythe, professor of casting at the University of Birmingham School of Metallurgy, states in a video presentation delivered in 2019, analyzing all available data, that the fact that de Havilland put oval windows into later marks is not because of any squareness of the windows that caused failure. De Havilland went to oval windows on the subsequent marks because it was easier to redux them in, use adhesive, nothing to do with the stress concentration, and it's purely to remove rivets from the structure. Surviving Comet 1s can be seen on view at the RAF Museum Cosford and the de Havilland Museum at Salisbury Hall, London Coney. Response, edit. In responding to the report, de Havilland stated, "Now that the danger of high-level fatigue in pressure cabins has been generally appreciated, de Havilland's will take adequate measures to deal with this problem. To this end, we propose to use thicker gauge materials in the pressure cabin area and to strengthen and redesign windows and cutouts, and so lower the general stress to a level at which local stress concentrations, either at rivets and bolt holes or as such may occur by reason of cracks caused accidentally during manufacture or subsequently, will not constitute a danger." The Cohen inquiry closed on the 24th of November, 1954. Having found that the basic design of the Comet was sound, and made no observations or recommendations regarding the shape of the windows. De Havilland nonetheless began a refit program to strengthen the fuselage and wing structure, employing thicker gauge skin and replacing the rectangular windows and panels with rounded versions, although this was not related to the erroneous square window claim, as can be seen by the fact that the fuselage escape hatch cutouts, the source of the failure in test aircraft GRU, retained their rectangular shape. Following the Comet inquiry, aircraft were designed to fail-safe or safe life standards, though several subsequent catastrophic fatigue failures, such as Aloha Airlines Flight 243 of the 28th of April, 1988 have occurred. Resumption of service, edit. With the discovery of the structural problems of the early series, all remaining Comets were withdrawn from service, while de Havilland launched a major effort to build a new version that would be both larger and stronger. All outstanding orders for the Comet 2 were cancelled by airline customers. All production Comet 2s were also modified with thicker gauge skin to better distribute loads and alleviate the fatigue problems. Most of these served with the RAF as the Comet C2. A program to produce a Comet 2 with more powerful avons was delayed. The prototype Comet 3 first flew in July 1954 and was tested in an unpressurized state pending completion of the Cohen inquiry. Comet commercial flights would not resume until 1958. Development, flying and route proving with the Comet 3 allowed accelerated certification of what was destined to be the most successful variant of the type, the Comet 4. All airline customers for the Comet 3 subsequently cancelled their orders and switched to the Comet 4, which was based on the Comet 3 but with improved fuel capacity. Bork ordered 19 Comet 4s in March 1955, and American operator Capital Airlines ordered 14 Comets in July 1956. Capital's order included 10 Comet 4As, a variant modified for short-range operations with a stretched fuselage and short wings, lacking the pinion, outboard wing, fuel tanks of the Comet 4. Financial problems and a takeover by United Airlines meant that Capital would never operate the Comet. The Comet 4 first flew on the 27th of April, 1958 and received its certificate of airworthiness on the 24th of September, 1958. The first was delivered to Bork the next day. The base price of a new Comet 4 was roughly £1.14 million. £29.95 million in 2023. The Comet 4 enabled Bork to inaugurate the first regular jet-powered transatlantic services on the 4th of October, 1958 between London and New York, albeit still requiring a fuel stop at Gander International Airport, Newfoundland, on westward North Atlantic crossings. While Bork gained publicity as the first to provide transatlantic jet service, by the end of the month rival Pan American World Airways was flying the Boeing 707 on the New York-Paris route, with a fuel stop at Gander in both directions, and in 1960 began flying Douglas DC-8s on its transatlantic routes as well. The American jets were larger, faster, longer-ranged and more cost-effective than the Comet. After analyzing route structures for the Comet, Bork reluctantly cast about for a successor, and in 1956 entered into an agreement with Boeing to purchase the 707. The Comet 4 was ordered by two other airlines. Aerolíneas Argentinas took delivery of 6 Comet 4s from 1959 to 1960, using them between Buenos Aires and Santiago, New York and Europe, and East African Airways received 3 new Comet 4s from 1960 to 1962 and operated them to the United Kingdom and to Kenya, Tanzania, and Uganda. The Comet 4AM ordered by Capital Airlines was instead built for B as the Comet 4B, with a further fuselage stretch of 38 in, 970 mm, and seating for 99 passengers. The first Comet 4B flew on the 27th of June, 1959 and B began Tel Aviv to London Heathrow services on the 1st of April, 1960. Olympic Airways was the only other customer to order the type. The last Comet 4 variant, the Comet 4C, first flew on the 31st of October, 1959 and entered service with Mexicana in 1960. The Comet 4C had the Comet 4B's longer fuselage and the longer wings and extra fuel tanks of the original Comet 4, which gave it a longer range than the 4B. Ordered by Kuwait Airways, Middle East Airlines, Misr, later Egyptair, and Sudan Airways, it was the most popular Comet variant. 1. Malaysia-Singapore Airlines Comet 4 at Kai Tak Airport in 1966. 2. United Arab Airlines Comet 4C at Geneva Airport in 1968. 3. Comet 4 of East African Airways at London Heathrow in 1964. Later service, edit. In 1959, Bork began shifting its Comets from transatlantic routes and released the Comet to associate companies, making the Comet 4's ascendancy as a premier airliner brief. Besides the 707 and DC-8, the introduction of the Vickers VC-10 allowed competing aircraft to assume the high-speed, long-range passenger service role pioneered by the Comet. In 1960, as part of a government-backed consolidation of the British aerospace industry, de Havilland itself was acquired by Hawker Siddeley, within which it became a wholly owned division. In the 1960s, orders declined, a total of 76 Comet 4s being delivered from 1958 to 1964. In November 1965, Bork retired its Comet 4S from revenue service. Other operators continued commercial passenger flights with the Comet until 1981. Danair played a significant role in the fleet's later history and, at one time, owned all 49 remaining airworthy civil Comets. On the 14th of March, 1997, a Comet 4C serial XS235 and named Canopus, which had been acquired by the British Ministry of Technology and used for radio, radar and avionics trials, made the last documented production Comet flight. Legacy, edit. The Comet is widely regarded as both an adventurous step forward and a supreme tragedy. The aircraft's legacy includes advances in aircraft design and in accident investigations. The inquiries into the accidents that plagued the Comet 1 were perhaps some of the most extensive and revolutionary that have ever taken place, establishing precedents in accident investigation. Many of the deep-sea salvage and aircraft reconstruction techniques employed have remained in use within the aviation industry. In spite of the Comet being subjected to what was then the most rigorous testing of any contemporary airliner, pressurization and the dynamic stresses involved were not thoroughly understood at the time of the aircraft's development, nor was the concept of metal fatigue. Though these lessons could be implemented on the drawing board for future aircraft, corrections could only be retroactively applied to the Comet. According to de Havilland's chief test pilot John Cunningham, who had flown the prototype's first flight, representatives from American manufacturers such as Boeing and Douglas privately disclosed that if de Havilland had not experienced the Comet's pressurization problems first, it would have happened to them. Cunningham likened the Comet to the later Concorde and added that he had assumed that the aircraft would change aviation, which it subsequently did. Aviation author Bill Withun concluded that the Comet had pushed the state-of-the-art beyond its limits. I don't think it is too much to say that the world changed from the moment the Comet's wheels left the ground. Tony Fairbrother, manager, upgraded Comet development. Aeronautical engineering firms were quick to respond to the Comet's commercial advantages and technical flaws alike. Other aircraft manufacturers learned from, and profited by, the hard-earned lessons embodied by de Havilland's Comet. The Comet's buried engines were used on some other early jet airliners, such as the Tupolev Tu-104, but later aircraft, such as the Boeing 707 and Douglas DC-8, differed by employing pod engines held on pylons beneath the wings. Boeing stated that pod engines were selected for their passenger airliners because buried engines carried a high risk of catastrophic wing failure in the event of engine fire. In response to the Comet tragedies, manufacturers also developed ways of pressurization testing, often going so far as to explore rapid depressurization. Subsequent fuselage skins were of a greater thickness than the skin of the Comet. Variants, edit. Comet 1, edit. The Comet 1 was the first model produced, a total of 12 aircraft in service and test. Following closely the design features of the two prototypes, the only noticeable change was the adoption of four-wheel bogie main undercarriage units, replacing the single main wheels. 4 Ghost 50 Mk1 engines were fitted, later replaced by more powerful Ghost DGT-3 series engines. The span was 115 feet, 35 m, and overall length 93 feet, 28 m. The maximum takeoff weight was over 105,000 pounds, 48,000 kilograms, and over 40 passengers could be carried. An updated Comet 1AM was offered with higher allowed weight, greater fuel capacity, and water methanol injection. 10 were produced. In the wake of the 1954 disasters, all Comet 1S and 1As were brought back to Hatfield, placed in a protective cocoon and retained for testing. All were substantially damaged in stress testing or were scrapped entirely. 2 Comet 1X, Two of Comet 1s were rebuilt with heavier gauge skins to a Comet 2 standard for the fuselage, and renamed Comet 1X. 3 Comet 1XB, 4 Comet 1s were upgraded to a 1XB standard with a reinforced fuselage structure and oval windows. Both 1X series were limited in number of pressurization cycles. For the DH-111 Comet bomber, a nuclear bomb-carrying variant developed to Air Ministry specification B-35/46, was submitted to the Air Ministry on the 27th of May, 1948. It had been originally proposed in 1948 as the PR Comet.